for the next part of this section, I do want to start out with these two equivalencies up here on the board. And we're going to talk next what are called power reducing formulas. And as we work with these, hopefully that will become more clear what that means. Okay, let's take the left example, the left equation here, and I want to solve it for sine squared u. So I'll subtract 1 from both sides. I'm going to divide everything by -2. I don't want the negative sign with it. And when I simplify this, hopefully I don't freak any of you out, but the negative on the 1 over the negative on the 2 makes a positive 1/2 there. And the positive cosine u over negative 2 is a negative ratio. So I'm going to put the 1 first and the cosine to u last. If we come over to the right equation and we want to solve it for cosine squared of u, okay, don't get ahead of yourself. Well, I'm going to write it the same pattern. Cosine squared u is 1/2 times 1 plus cosine 2u. Okay, now your author will write it as one big fraction, like I have it on the left side up there. 1 plus cosine 2u all divided by 2. I like to put the 1/2 out in front of the quantity. Write it however you work with it best. Okay, at your home in your work. We call these power reducing formulas because that's what they did. I started out with a sine squared of an angle. I started out with a cosine squared of an angle, and now I can write it as a trig function to the first power. Now, what I give up or gain, depending on the situation, is that it's no longer, the angle is no longer u. I've had to double that angle. Okay. But if I need the cosine, if I need sines or cosines to the first power instead of squared, this will help me get that power reduced down. If I want to find the tangent squared of u, I want to power reduce that. We know that tangent of an angle is sine of that angle over cosine of that angle. Okay, so tangent squared would be sine squared u over cosine squared u. Using the power reducing formulas from up above, I can copy and paste them down in. And the only thing I can do to reduce this is I can knock out those 1/2s. Okay, the tangent squared of an angle is 1 minus cosine twice that angle over 1 plus cosine of twice that angle. These are the power reducing formulas. They're found in that right column on the note card in the back of your book on that cardboard flap there. So if I'm wanting to use those, maybe I have sine squared x. Okay, all I'm doing is changing the u into an x here. I'd have 1/2 1 minus cosine 2x. If I have sine squared 6x, then when I power reduce, I want to write it to the first power. Notice and remember that my u turns into a 2u. So my 1x turned into a 2x. My 6x is going to turn into 12x. I could be creative again. That's not what I want. We don't have to do this very often, but every once in a while, something special like this jumps out, and I say, well, I have sine squared. I need something to the first power. So when I double the angle x over 2, 2 times x over 2 just gives me x. This is actually going to be something that I see again in the next video. So, and this would, the only thing different if I would change any of those signs into cosines is there would be a plus sign right here instead of the minus sign all the way down. Now let's say that I want to, I know you hear me rustling my papers. If I don't follow my path, I end up willy-nilly all over the world. Okay, so I'm trying to be sort of organized in this process. If I have sine to the fourth of 2x, and the main times that you guys are going to need to power reduce something and reduce it from a squared to a first power. In calculus, as you get a little bit more in depth, there are things that we can't do with sine squared x, or cosine to the fourth x, or tangent to the sixth x, but we can if we have sine to the first or cosine to the first power. And it doesn't matter what the angle is, whether it's cosine x or cosine 2x or cosine 12.9x. We need the cosine to be to the first, regardless of the angle. Now, unfortunately, when we are reducing powers, it does not take a very big power of x to make these a nasty problem. I'm not going to ever have you power reduce sine to the 10th power. Really, we're probably not going to go beyond 4 because that is nasty enough. If I have sine to the fourth power, that's sine squared squared, which means I have 1/2 times 1 minus cosine of double 2x, that quantity squared. When I square this, I'm going to square the 1/2 and call it 1/4. If I have to square 1 minus cosine 4x, don't forget that means I'm taking it times itself. Some of you know that binomial expansion by heart. You know the shortcut and you can do that in your head. Some of you do not know what I'm talking about, and so you need to write it side by side. Okay, once you write it side by side, you're going to FOIL. If you need to pause the video so you can do that and get caught up, please do. But then look what I have here. Because my goal is I need to get things down to the first power. And regardless of the angle could be 1x or 2x or 257x. But I need the sines and cosines to be to the first power. I got that started here. I can distribute and say, well, that's 1/4, and that's minus 1/2 cosine 4x. But I still have a cosine squared term right here. Cosine squared of 4x. Which means I get to power reduce again. When I am reducing all the way down to first degree terms, that means I get to power reduce over and over. Okay, sometimes. Cosine squared 4x. I'm going to put brackets there, and I'm not going to recopy the first terms and be lazy. Just going to write right here. Is 1/2 times 1 plus cosine, double the angle. I double it to 8x. So now I'm going to bring everything together. Hopefully I'm not being too confusing in my notation here. But notice if I distribute this 1/8 to here and 1/8 to there, I have 1/8 plus 1/4 cosine 8x. I can put my 1/4 and my 1/8 together and call it 3/8. I need to go up one more time, sorry. 3/8. I have the minus 1/2 cosine 4x term. I have my plus 1/4 cosine 8x term. And there I stand. This was just, if I can fit it all in, reducing something from the fourth power. If I have a sixth power, I'm going to get to take it from the sixth power down to I'm gonna have to cube something, and then anyway, it's gonna be over and over again. So practice these. Go look through the examples. Your author has some in the book. See me if you need me.